Today we are going to present journal reflection entitled Energy Recovery from Wastewater Treatment Plant in the United States. Wastewater treatment, known as sewage treatment, whereby the treatment removes contaminant before release it to the river, stream, ocean or lake. It uses high amount of electricity. And this paper study case from Texas, which is a state from United Kingdom that consume and produce higher electricity than any other state. And this paper emphasizes more on modification of wastewater treatment plant that can help reduce high energy consumption through two processes, which are anaerobic digestion and biosolid incineration. Anaerobic digestion with biogas utilization. The sludge can be referred as biosolid form after being digested. There are two types of digestion, which are aerobic and anaerobic digestion. Aerobic digestion use oxygen to facilitate the microorganism to produce biosolid and other products, while the anaerobic digestion does not use oxygen to produce biogas containing methane and biosolid. This paper records that biogas can be used as a source of fuel to generate electricity. Next, biosolid incineration with electricity generation. Biosolid need to be further disposed through composting, landfilling, and land spreading. An alternative way to dispose the biosolid is through incineration, which is highly cost than the other three methods. And there are two types of equipment used in this process, such as multiple hell furnace and fluidized bed furnace. And this paper records that heat produced from biosolid incineration is transferred to the steam cycle, causing turning of turbine connected to generator, resulting generation of electricity.
So, for the methodology of these case studies, there were two approaches being done. First, the anaerobic digestion with biogas utilization. The potential energy recovery has been calculated for three cases in US and Texas. These three case studies illustrate the range of energy recovery possible through anaerobic digestion with biogas utilization. Case 1, representing current operation in the baseline. Case 2, show possible of energy recovery by utilizing the production of biogas instead of disposing by flaring. Case 3 show full potential of energy recovery from this approach. For second method, the potential recovery has been calculated for two cases, but there was no tests. Wastewater treatment plants report electricity generation from biosolid. However, these two cases show potential energy recovery if such biosolid disposal methods were implemented widely.
In this result, I want to emphasize case 83, whereby all wastewater treatment plants utilize biogas in United States and Texas. Next, case B12, whereby all wastewater treatment plants implement incineration process in United States and also in Texas. Therefore, first way is all wastewater treatment plants utilize biogas, which is it represents the full potential of anaerobic with biogas utilization. In US, total electricity consumption for wastewater treatment plants was estimated at 18,100 to 20,800 million kilowatt per year. Therefore, by using these treatment plants that utilize biogas, the US can decrease the amount of electricity consumption from 2.6% to 27%. Meanwhile, in Texas, the total electricity consumption for wastewater treatment was estimated at 1,800 to 1,950 million kilowatt per year. In Texas, they can save up to 26% from 2.1%. Next is all wastewater treatment plants implement incineration process, whereby it represents the full potentials of biosolid incineration with electricity generation. Therefore, in US, they can save by 2.5% to 27%, and in Texas, they can save up to 57% from 2.7%. Hence, from this study, they can prove that biogas utilization and biosolid incineration can produce total energy recovery for the wastewater treatment plants to be operated. And they can save the electricity consumption in US and in Texas. Next, the comparison of energy recovery between biogas utilization and biosolid incineration. The range of potential energy recovery is higher for anaerobic digestion at 139 to 208 million kilowatt per year than in biosolids incineration at 51.9 to 80.8 million kilowatt per year. Next, energy recovery in anaerobic digestion with biogas utilization is 661 to 1030 million kilowatt per year, more than the biosolids incineration, whereby they recorded 307 million to 460 million kilowatt per year. That is, biosolids have more inherent energy than biogas when used to generate electricity.
Next, we'll be discussing on the implication of utilizing the biosolids incineration and the biogas from anaerobic digestion. There are 4 implications. First, reducing the emission of the greenhouse gas. Second, reducing the future growth of energy needs in wastewater sector. Third, slowing or mitigating the energy consumption in wastewater sector. And lastly, policy changes. The emission of greenhouse gas can be reduced by decreasing the amount of grid electricity required for operation. Digester biogas utilization and biosolid incineration produce fewer greenhouse gas and critical air pollutant emission. Future energy needs for wastewater sector can be reduced by utilizing the biogas produced from the anaerobic digestion. This plan can be further implemented gradually for other treatment plants. The energy consumption in wastewater sector can be slowed by implementing the biosolid incineration to generate electricity. Cost saving is possible through electricity generation and the sale of electric power grid. Policy changes by the state, the federal and the local government because of potential energy saving through utilization of the biosolids incineration and the biogas from anaerobic digestion. US EPA might consider to design energy recovery through biosolid incineration under municipal biosolid policy, and might encourage coupling energy recovery with adequate wastewater treatment.
Next, we will look into the conclusion part. The relationship between the energy and water and the organic content of wastewater can encourage energy recovery activities. These energy recovery activities can be made from various types of sources, such as municipal wastewater treatment facilities. To reduce the usage of electricity in wastewater treatment, anaerobic digestion with biogas utilization is strongly being executed. With rising concerns about emerging water contaminants such as pharmaceuticals and personal care products, wastewater treatment is likely to become more energy intensive in future. Next, we will look into the reflection part of this journal reflection. Energy recovery is inextricably related to the prevention and minimization of waste products. This energy recovery can eventually valorize the waste that occur, and hence this can reduce the environmental and economical impacts. Besides, electricity and heat which is generated from wastewater provides us an alternative and more environmental friendly source of energy. Last but not least, together with this energy conservation, it should also be possible to dramatically reduce the world energy consumption. Thank you.